Hi team, so we are going to be converting a mixed number, a number with some wholes and some leftover parts, into an improper fraction, right? Where the numerator is bigger than the denominator. So we're going to start by using a visual strategy as we sort of think about what it is that is happening here. So if we go ahead and sort of create this visual, it can help us interpret what is happening. So we have 3 wholes and 4/5 kind of left over, right? Or 3 wholes and 4/5. So what that tells us is that our pies, if you will, are going to be cut up into 5 parts, right? Because it's going to take 5 of these to create one whole. So if we color in 5 of them, it will get us a whole. Well, we're going to do that how many times? We're going to do that 3 times. So we'll color in all 5 of these and all 5 of these. And then we can't do it any more whole times, but we can do it this many extra pieces are what we're looking to color in, right? So we're going to color in 1, 2, 3, 4 out of a potential of 5. That's what 4/5 sort of looks like as a visual. So our next step then is to say, okay, well, how can we use this information? Well, what we're going to do is we're going to count up how many total pieces we've colored in. So we've colored in 5, 10, 15, 16, 17, 18, 19. We've colored in 19 total of what size piece? Well, we've colored in 19 fifths, where it would take five of the pieces to make one whole. So we have 3 and 4/5 as you convert it into an improper fraction, turning into 19 fifths. Now, another way we can kind of interpret this that's a little bit of a shortcut using multiplication and then addition is using these visuals. We did this same thing. We just sort of put it on paper or on a screen here to visualize it, right? But what we did is we took 3 whole pies that were each cut into the fifth side, 5 pieces each, right? So in other words, we took 1, 2, 3 fives, right? Or 3 5 times, or 5 3 times, whichever way you want to think about it. So we did 5 times 3 is essentially what we did, right? It takes 5 pieces and we did that 3 times. 5 pieces to make a whole, 3 times. Yeah. So then we have these kind of other pieces over here and we want to add those on. So we'll say we had 5 times 3, which was our 15, and now we need to add on our leftovers. So we're going to add on 4. And when we do that, we end up getting the same thing, which is 19 fifths. Fifths because that's how many pieces it takes to make a whole, because our denominator is 5. So we could think about doing another example here, kind of with that shortcut, right? And you can visualize it. You can even write the pictures, right, of thinking about how to interpret this. So what this is saying is we have 2 whole pies, each sliced into how many slices? Well, into the denominator amount of slices, which in this case is 11. So we're going to do 11 to make one pie, right? And 11 to make another pie, which ends up being 11 2 times, which is 22. So 11 2 times, which is 22. 2, 2, 2, 2. And then, so we've done 11 times 2, and then we're going to add on those leftovers, right? Because we'd have another pie sliced into 11 parts and take 9 of them, leaving us 2 not filled in. So we would have 22 plus 9, which is going to help us get our new. So you might think of 22 plus 10 is 32 minus 1 is 31, and it's going to be out of 11, right? It takes 11 pieces to make a whole. Our denominator stays the same. So to sort of wrap up the shortcut, right, you're taking your denominator, you're multiplying it by the whole number, and you're adding on your numerator as those leftovers. This converts the mixed number to an improper